Hi everyone and welcome to this webinar on building VR experiences with Twinmotion. In this webinar, we're going to cover some key VR related concepts that should help you get the most out of your VR projects. First up, we'll go over some basic setup information which will be required to get started. Twinmotion VR requires only a click or two to run, but there are a few things we'll need to first do on the VR hardware and software side. After that, we'll jump right into the VR scene we're using today and go over the basic VR navigation controls, as well as looking at how to jump around the scene using the presenter view, how to change materials, and how to tweak time of day and weather. Then, we'll look at how to add life to our scene by adding some animated vehicles and characters, as well as interactive doors. From there, we'll cover some of the important performance considerations when developing for Twinmotion VR and how to get the most out of your application. Finally, we'll look at how to build the final shareable application. Let's get started. Twinmotion supports several VR platforms. As you can see from the list here, it supports Oculus Rift as well as Rift S, Oculus Quest 1 and 2. We'll be using Oculus Quest 2 today for our setup, as well as HTC Vive, HTC Vive Pro, Cosmos, and Cosmos Elite. Then also Valve Index, and finally Windows Mixed Reality devices. As I said, we'll be using Oculus Quest 2 today, and we'll be using the link cable so that we can essentially run it like a Rift. And the Oculus Quest 2 supports a resolution of 1832 by 1920 per eye, and it runs at a refresh rate of anywhere from 60 to 90 Hertz. Keeping in mind some basic rules of VR, maintaining that consistent 60 to 90 Hertz refresh rate is pretty important if you want to avoid simulation sickness for your user. And of course, we don't want to have any stuttering or any black frames or anything like that. All of that stuff contributes to simulation sickness or VR sickness. And of course, in our performance section, we'll talk about some of the things we can do to make sure we're maintaining that frame rate. Now, before we can get started inside of Twinmotion, there are some setup things we need to do for our VR headset, and every VR headset setup is going to be different, obviously, but mostly the same. Now, in the case of the Oculus Quest 2, of course, not only do we need the headset itself, the HMD, but we're also going to need the Oculus Link cable, which is essentially a USB 3 or Thunderbolt cable. These cables are pretty important. There are a lot of knockoff cables out there that you can purchase for cheaper, but I found that the Oculus Link cable from Oculus itself tends to work the best. We'll also need to go ahead and sign up for an Oculus account at the link provided. And then we'll need to install the Windows Oculus Link application at oculus.com/setup. Now, with all of our software set up and we're ready to put our VR headset on, you're going to notice when your Oculus is plugged into your PC using the direct link cable, you should get a pop-up window asking you to enable direct link. And of course, you want to say yes on this. All right, and our setup is all complete. We should be ready to go inside of Twinmotion. Now, going to VR within the Twinmotion editor is actually quite easy. All we need to do is go up to the top right. You'll see this eye menu here. Click that. Then we can click VR and then Start VR. Now here inside of Twinmotion, you're only going to get the one eye here rendered out. But if we want to see this full screen, we can actually use an Oculus development tool. To find the tool, if we go to our C drive and then Program Files and then Oculus, we can go into the Support folder and you'll find Oculus Diagnostics. And then the application is called Oculus Mirror. In the Oculus Mirror, we can click on the very top here underneath the title bar and then click on Settings. And we're going to set Crop to Symmetric FOV, and then we'll go full screen. Okay, so we're mirroring our Oculus HMD inside of our computer here. Keep in mind it's running a little slow, and that's because I'm capturing on the same computer that I'm also using the Oculus Link on. Let's take a quick look at our menu now. My left hand controls the menu, and then my right hand is used for navigation. With navigation, I can point at the spot I want to go and simply click the trigger to go there. Now the menu is a little different than what you see in presenter mode, and we'll see that later on. But if we click on settings, we can actually go to our quality settings here. So we can go to low here and see the lower quality settings, then medium, and then we can go up to high. And so each time we're going up, we're getting a little bit better. All right, so let's jump back to our root menu. We can also go under weather and change time of day and weather effects. So here I'm using the slider to change it to nighttime, and then I can change it back to daytime. Let's go back up to our root menu. We can also change the materials of our scene. So let's change the material on the floor here. So let's go to wood, and then we'll grab this wood here and then simply drag it onto the floor, and you can see there that it changes. And these changes are made so that when you go back to the editor, those changes will be kept there. Let's do the same on this concrete here. We'll go to concrete, and then we'll change it to this concrete slabs 01. So this allows you to edit materials in the viewport, but we can undo those changes too using the undo button and go right back to where we were. All right. Now, if I go close to the doors over here in this particular scene, I've set it up so the doors are interactive. They will open up for you as you get close to them. So we can go inside the room here. And then if we turn around, you can see that the doors have closed behind me. Now I can also go down to the street level using the presenter option here. So we'll click on that, and you can see I've got an interior view and a street view. So let's go ahead and use the street view, and that will teleport me out of the interior down to the street level, where I can look around and move around the scene just like I could before. Now if I want to go back to my interior, I'll simply click on this interior view, and that will take me to the interior view camera. Let's add some life to our scene here by adding some characters and some vehicles, as well as some interactive doors. Let's start out by adding some characters to liven the place up. We can do that by going to our top left menu here and then selecting characters. We have several options here. We can put groups or animated humans, as it says. Let's go ahead and put some animated humans here. I'm going to just drag this first guy, Amir, here into my scene, and then I'll rotate him towards the counter. Let's go ahead and rotate him a little further towards the counter, and maybe we'll drop in Emily here, and we'll point her towards Amir and let them have a little conversation. There we go. And if I wanted to use a group, I'd go back up and go to groups, and then let's go ahead and grab group 2 here, and let's just drop them in off to the side there. All right, so that's how we can very easily add some basic characters to our scene. These characters don't move around, but they animate and add a little bit of life to the environment. But let's look at how we can now add some characters that actually walk through the scene. I'm going to jump down to my street level, and you can see here in the street level we have some characters that are following a path. Let's look at how to add them in now. So to add characters on a path, we need to go to the context menu, and then we'll go to paths. And from here we want character path, and we're going to select the pen tool, and then we'll need to draw a path through the scene. So for instance, if I wanted to add a path here, I'd go ahead and just click back there, and then we'll click right here, and then maybe I'll do a little bit of a jog around the corner here and then head back further that way. Once I'm done, I can right click. You can see here we have these plus buttons here, and this allows me to add other path nodes if I need to make adjustments. You can see though that the characters are already moving on the path, but let's go ahead and make a couple of adjustments here. First of all, I'm going to change the width so it's a little wider so they're taking up more of the path. I can control the density here, so obviously if I want more people, I'll drag that slider up. But keep in mind this is going to affect your performance, so we're going to keep this down somewhere closer to about 10%. Now if we want to add some vehicles, we can use the exact same tool. We'll go to Paths, and from Paths we'll go to Vehicle Paths. Once again, we just need to select the Vehicle Path pen tool here and draw our vehicle path here. Now what I want to do is I've got 4-lane street here, and I want the vehicles to take up all 4 lanes. So I'm going to draw the path right in the middle here, and we'll just draw it all the way down to the end there. Okay, so our vehicles are now moving, but we're only getting 1 lane of traffic here, so let's go ahead and change our lane count to 2, and let's turn 2 lanes on, and that now gives us 4 lanes of traffic, 2 in each direction. But we need to adjust the offset so that they fit more properly on our road here, so let's go ahead and widen that out. And there we go. Just like before, we can control the density. Let's go ahead and bring this down to about 25%. We could also change the speed at which the cars are moving, but we'll just go ahead and leave that for now. Now, typically when you're creating a path like this for people or cars, you don't want it to end abruptly like that. If the user is able to see that part of the scene, you want to make sure that they make a turn going around a building or something where the user will not see them popping in and out. So if I wanted to do that very quickly, I could simply go back and select my path tool. So let's do a quick search for path. All right, and select my vehicle path tool. So we'll need to select this last path point here, or the starting point, and then click our ink pen button. And this will allow us to add some more points. So we'll go ahead and click here, and then we're basically making a nice turn. All right. So now when we're back over here, and we look in that direction, the cars will no longer simply pop in and out of existence. They'll come around the corner. The last thing we want to do in our scene is to add some interactive doors that your users can walk through. So currently we have a few doors in the scene here, and if you were to try to go through these right now, you would simply pass through the doors. But what we want is for these doors to actually open up when the user gets close enough and then to close behind him. You can see that with the move tool selected on the door, the axis, the center or the rotation point of the door is right on the edge here where it connects with the rest of this glass wall. So if I were to rotate that, the doors will rotate properly. So this was done inside of the DCC tool. I just made sure to set my pivot point at the right spot. So to rotate the door, we're going to use what's called a rotator. We're going to find this up here on our top left menu, and then we'll go down to Tools. From here, we will go to Animators, and we have two animators. We have a rotator and a translator. So the rotator is what we want in this case, but we could also use a translator for sliding doors like pocket doors or anything that slides left and right or up and down. This is great for that, but we want the rotator. Now we have a couple of options here we could use. We could just throw in this rotating door here. You can see as I get close to it, the door opens up. But we want to use this door instead of using one of these built-in doors. So let's go ahead and do that using this rotator itself here. So let's drag that into the scene. All right, and now we need to position it right next to the edge of our door. We want to line that up fairly well with the edge of our door. Okay, so now we simply need to parent our door onto the rotator. So let's go ahead and select that door. And I'm going to drag it onto the rotator. Okay, so now the rotator is doing its job, but it's not doing exactly what we want it to do. So let's go ahead and select the rotator. And let's look at some of these options here. First of all, we can turn it off so it's not doing anything. But let's go ahead and turn it back on so we can see the effects of any changes we make. We can change the angle here so we can determine how wide it opens. We can also flip it so that it opens in a different direction. So let's go ahead and set it to -90. We can also change the type of animation. Right now it's doing ping pong, so that means it's opening and closing back and forth. So if we click on that, we can change it to once or loop. So loop doesn't ping pong, but it does continue to play the opening animation from start to finish. And what we want is once. We want it simply to open and stay open and then close when we're not next to it. We can also control the speed of how fast it animates. Now we need to set a trigger. So let's go ahead and turn our trigger on. And it will go to more, and we want to make sure the trigger type is set. So we're going to leave all of this, but basically you can set it so only cameras trigger it, pedestrians, any characters we put into the scene that move through the door, vehicles, and so forth. And we can also control the trigger zone, how far away from the door that the door will open. So if I were to set this to, say, 6 meters, then you can see that the door will open from very far away. So let's go ahead and put this back down to 3 meters. So now if I move towards the door and then go through it, and then get far enough away, the door will close behind me. Perfect. So now we simply need to do the same thing for the other door. So once again, we'll drag a rotator into the scene and line that up with the edge of the door. And then we'll select this other door and drop it on the rotator. Once again, we'll change the rotator settings. Turn the trigger on, and we're good. Perfect. And of course, this will work in VR as well. So when you're teleporting through the room, if you go up to the doors, they will open for you. And when you pass through them, they will close behind you. All right, so now that we've got some interaction and some life added to our scene, let's talk a little bit about performance for VR. Now, for virtual reality, it's typical that you should maintain something close to 90 frames per second. And if you don't maintain this frame rate, your VR simulation can cause people to get motion sick. Now, the Oculus Quest 2 runs somewhere between 60 and 90 frames per second. And in the case of Twinmotion, we want to hit the 72 Hertz frame rate. But how do we know we're hitting this frame rate? Well, there are a couple of options we have available to us. First of all, inside of the editor, we have a statistics tab. So if we go over to the far top right here of our editor viewport, and we click that arrow there, on the very bottom, you can see the word statistics. We'll open that up with this arrow next to it. So from here we can see our frame rate. So obviously right now we're nowhere near where we need to be. It's running fine in the editor viewport, but we do need somewhere between 60 to 90 frames per second for our Oculus Quest 2. This also tells us things like the amount of GPU being used, the amount of CPU being used, as well as our poly count. You can see here we have 13.7 million polygons. Then we have our number of objects. That's going to be 1,000. We'll talk more about this when we talk a little bit about draw calls and how the object count affects your draw calls. We have our total amount of textures right at about 8 gigabytes. So we're going to have to do some things to bring this frame rate up. Well, we'll talk about that in just a second. First, let's look at our second option for judging the frame rate. We can actually see the frame rate inside of our Oculus HMD. We'll find this program for doing this inside of our C program files directory and then Oculus. Then we'll go to support, and from here Oculus Diagnostics, and in the Diagnostics folder we want to find the debug tool. So let's go ahead and open Oculus Debug Tool. So this gives us a bunch of options for debugging with our HMD, but all we're really interested in right now is the visible HUD here down at the bottom. We want to change that from none to performance, and then we can close that. Now let's run our scene in VR. So you can see inside of the headset, in the side of the HMD here, we have a little pop-up window towards the top there. And it gives us our Oculus performance. Now, obviously I'm running very poorly right now. That's because I'm capturing on the same computer that I'm exporting out using the link cable, I'm exporting out to my Oculus. So according to the Oculus performance log here, the debug tool, we're only getting about 15 to 18 frames per second. So that's even worse than what we were getting inside of the editor. But let's take a quick look if I were to change some of the settings here. Now you can see I'm getting very poor frame rate here. I'm getting a lot of glitchiness, and that's because we haven't done any optimization yet. But let's go to the settings here, and let's change the quality down to low. And look how the frame rate jumps up. Now we're getting about 36 frames per second. So it's considerably different. But of course the scene does not look anywhere near as good because we don't have any shadows. So let's go ahead and move it up to high. And that should take us back to where we were. So to correct some of our performance issues here and try to get our frame rate up a little higher, there are a few key areas that we can look at. First of all, we're going to look at lighting and shadows, and those can be very expensive because everything that we're dealing with here is real time. The lighting and shadows are not baked into the scene. After that, we'll look at some screen space post-processing effects, such as screen space reflections and global illumination. Those can also be quite expensive. And then the third thing we're going to look at is how to work with draw calls, how to reduce those draw calls, which again can be expensive. And then last of all, we'll take a quick look at the Twinmotion quality settings and how you can adjust those. So let's start out with lighting and shadows. So right now, keep in mind, look at the frame rate here we're getting. We're getting about 48 frames per second here, but we're going to play with some of the lighting in the scene and see what that does. So if we go over to our Explorer here, our scene graph, and let's go ahead and open our lighting folder. We're going to change some of the values on these lights. So first of all, I'm going to select this IES light here. Now IES light is just basically a spotlight that has an IES profile in it to make it look a little more realistic. Now the two key things we want to work with here are going to be the attenuation radius and shadows. So the attenuation radius determines how far out from the origin of the light that the lighting effects will go. And the wider this attenuation radius is, the more expensive it will be on the scene. Now, most of my lights here in this scene are instanced, so when I make changes to one light, it's going to change a lot of other lights. So let's go ahead and change the attenuation radius here on this light, and let's see if we can tell a difference. So we're going to drop this down to 5 meters, and you can see right away that our frame rate nearly doubles just by doing that. So it's a little less bright, so if I go back to 10, you can see how much brighter it is. But it's still good enough, I think, in this case. Maybe we'll bring it up to 6 to get it a little bit brighter there. And remember, we're using instances, so if I select all of these other lights here, you can see that they're all set to attenuation 6 as well. So let's make sure that we don't have any lights here that aren't the same. So we'll go ahead and select these, make sure they're set to 6. And we'll do the same for all the rest of the lights in the scene. That's our kitchen lights. And then our work area lights, those should all be the same. All right, so we've set all of our attenuation radiuses to 6 meters instead of 10, and that's given us about 30 frames per second. So next up is going to be shadows. So the best way to work with shadows is not to have every single light project shadows, because they are very expensive. What you want to do is choose one key light in the area that's going to be your shadow caster, and then you can probably turn off the shadows on all of the rest of the lights. So let's go ahead and move into the conference room here to see an example. All right, and then you can see that just by my camera angle here too, I've changed my frame rate. So now I'm up to almost 90 frames per second. But let's go ahead and turn the shadows off on some of these lights. So we'll select one here and turn that off. And from there you can see clearly we've added another 40 to 50 frames per second just by turning those shadows off. Let's go ahead and toggle those again. And you can see clearly the difference. So you're going to want to basically play around with these values here, the attenuation and the shadows on all of the lights in your scene, and then try to get the look you're going for while using as little of an attenuation radius as you can and turn off as many of the shadow casting lights. Alright, and with all of our lights set to shadows being off except for a few key ones and our attenuations reduced, we're getting a much better frame rate already. So you can see here from that same viewpoint from before, we're getting about 160 frames per second. That's a huge difference. We're getting roughly 120 frames per second more than we were at the very beginning. Now the next thing we're going to want to look at is going to be our screen space post-process effects, and that includes screen space reflection and global illumination. So if we go to our settings button here, and then we can go to lighting, and under lighting we have our global illumination here. So if we go ahead and turn that off, you can see that we get a bit of a frame jump there. So let's turn it back on. And we're running at about 165 to 170 frames per second. Without global illumination, we jump up to almost 220, somewhere between 200 and 220. It seems to fluctuate there. But you can see the difference clearly. So again, here we are back on. We get a lot nicer distribution of our lighting with it on, and we get nice color bleed and bounce and such. And with it off, the scene all becomes much brighter. So you really got to decide, what's more important, the frame rate or the look you're going for. As long as we're hitting that 60 to 90 frames per second for the Oculus, we should be okay. So it might be okay to just leave this on. But if not, this is definitely something you're going to want to tweak. You're going to want to turn this off to get that higher frame rate. And next up is going to be screen space reflections. And we're going to find that, again, on our settings here under Camera, Visual Effects, Reflections. So screen space reflections, that's going to give us our nice reflections everywhere where we have reflective surfaces, and it's based on everything that is currently drawn on the screen. So anything that's off the screen, that's not going to be rendered in the reflection. It's only going to be things that are currently on the screen. But let's go ahead and turn that off and see what happens to our frame rate. Again, we're hitting about 165 frames per second. Let's turn that off. And we didn't really see much of a change there. So this one seems safe. Let's go ahead and move in a little closer here to something. We've got 220 frames per second. Let's turn it back on. Yeah, it doesn't seem to make a difference. So you can see the difference when I turn it on off visually, right? So if we turn it off, there's not a lot of reflection going on here. We turn it back on. Now you can see on the desk, on the table there, we're getting nice reflections. Likewise on the floor, we're getting some nicer reflectivity. And it doesn't seem to have much of an effect on the frame rate, so it might be safe to go ahead and leave this one on. So you want to keep in mind that your post-process effects may or may not have an effect. So, you're going to have to play with these values, toggle them on and off, see if it affects your frame rate. And if it doesn't, it's probably safe to leave it on. But keep in mind also that inside of the VR HMD, these settings may make a difference. So you're going to have to also try it in the Oculus HMD and see if the frame rate is any different. So one of the primary considerations for performance that you need to always be looking out for is going to be draw calls. Draw calls is when your CPU is telling your GPU to draw something. And the number of draw calls you have is based on the number of objects in your scene times the number of materials that those objects use. So if you had 10 objects and each of those objects had 4 materials, then you would have 40 draw calls, essentially. And the more draw calls you have, the more expensive it is for your video card to render the image. Now in this scene, we've got about 1,000 objects, and you'll notice as I click on the objects here, it's only clicking on each individual object and not the other objects that look just like it. None of the instances of that object are being selected, and that's because they're all separate. So that means in this case I have 1, 2, 3, 4, 8, 10 chairs, and each of these chairs has 3 materials, so that would be 30 draw calls. And indeed, the rest of the scene is built in much the same way. So if we go over here to these bookshelves, these are all individual objects. All of these books are individual objects, and the chairs, and the monitors, and on and on and on. And so we have a lot of objects in our scene, and that's going to really add up your draw calls. So there are a couple of options that we have available to us to reduce the number of draw calls. But ultimately, what you're trying to do is reduce the number of individual objects as well as their material complexity. So the first option available to us would be to go into our DCC tool and load up the source file. From here we can determine which objects that we want to merge into a single object. So for instance, let's say I want to merge all of these chairs into one object. So we'll just right click on that and choose Select Similar, and that should select all of the chairs for me. And then I can go to the Utility panel and choose Collapse, and then Collapse Selected. And now when I select these chairs, they're all part of the same object. So that's going to reduce the number of draw calls down significantly there. Now obviously there are some drawbacks to combining them like this. You're not going to be able to apply individual animations or anything like that to each chair because they're all a single object now. But if you don't need your chairs to move or anything like that, then this is what you'd want to do. The second option is going to be in our import options in Twinmotion. So if we go ahead and import a file, and then we open the options, you're going to see this collapse drop down here, and it should be defaulted to this value of collapse by material. The other option is keep hierarchy. Now when I first imported this scene, I chose keep hierarchy. Now what keep hierarchy does, it allows you to import the model as is without doing any kind of collapsing. So if each chair is a separate object, it'll stay a separate object. And this is basically going to import the scene as it is inside of your DCC tool. And of course, this is where you're going to have more objects and therefore more draw calls. Now, collapse by material will automatically merge assets or objects together into a single object if they share the same materials. So essentially what we just did inside of 3ds Max, where we selected all the chairs and we collapsed them into a single object, this is going to do the exact same thing, except the way it's going to do it is it's going to look for objects that have the same materials on them, and it's going to collapse those objects down into a single mesh. Let's go ahead and import it. Alright, so this is what the scene looks like when it's first imported. We don't have any materials on it in this case, but we can see under the statistics that this now has only about 0.4K objects or 400 objects as opposed to 1,000 objects. And that's because we collapsed by material. So if we look at these chairs, I'll go ahead and select one of them. You can see that all of the chairs that share that material have been combined into a single object. Likewise in here, if I select one of these chairs, you can see that the materials have been collapsed down to a single object. Now you will notice by doing it this way, you don't get the whole object. You only get each material separately. So in the case of these chairs, the top part has a material, then the legs have their own material, and so forth. So you want to keep that in mind. It might be better to do it yourself in the DCC tool by combining your objects. But if you're not concerned about that, if these objects are never going to be moved in your scene or interactive or anything like that, then this works very well for just a real quick way to reduce your draw calls. Now the last option available to us inside of Twinmotion for controlling our frame rate is going to be the quality settings. And we'll find these under the Edit menu and then go to Preferences. And from here at the very top, we want to select quality. So here in the quality settings, we have automatic setup. We can click that and it will try to determine what the best settings are for our machine. And then we have low, medium, high, and ultra settings. Click that and everything will be set to these values. Or we can use these individual drop downs to specify which of these options that we want changed. Now keep in mind that there are certain settings that are going to have the most impact or be the most expensive essentially in VR. First up is going to be effects. So you want to keep this one kind of low in VR. This can be very expensive. That includes things like particle effects and other things like that. Texture quality can be set to ultra. This really doesn't have much of an impact on your frame rate in VR. Shadows and post-processing, those are also quite expensive. They're not as expensive as effects, but they do have a considerable cost. So you're going to want to keep these down. Definitely setting them to ultra is going to cause you some issues, but probably high or medium is probably where you want to be on these. View distance and anti-aliasing shouldn't cause you any problems. But rather than try to figure these out individually, we can also scroll down a little further and you'll find this optimized VR quality. This was added in the most recent version of Twinmotion. And we can go ahead and enable this, and when we go to VR, it's going to automatically try to set all of the settings so that you get the best frame rate in VR while maintaining the best look. But let's have a look at what some of these settings do. Let's go ahead and move this over so we can see our viewport a little better. And then let's change our quality settings all to low, and then hit OK. So you can see here we have basically no shadows anymore. The post-processing effects are all turned off. No screen space reflections or anything like that are on. It's not looking very good. So this is going to be the worst setting. So let's go ahead and go back to our preferences, quality settings, and then we'll go up to medium. And so here now we're starting to get some of our things back. So we're getting more shadowing, though they're not as crisp, and post-processing effects and so forth are starting to look a little better. So this is a pretty decent view, but let's go ahead and pump it up a little higher. And let's set that to high. All right, so now we're looking really good. We're starting to get more crisp shadows. We've got better screen space reflections and better global illumination and so forth. And if you have a really good machine, of course, you can go ahead and set that up to ultra. And the shadows here are noticeably crisper, much nicer. But if you noticed, we go back to the lowest setting, take note of the frame rate. We'll set that to low. And you can see that it basically doubles from 120 something to 300 frames per second. So it's a huge difference. So keep that in mind. And of course, remember, the frame rate is going to be different in VR. So here you can see inside of our Oculus HMD using the debug tools, we're getting a solid 72 frames per second. There's a little bit of a dip there as we look around, but otherwise a very solid 72 frames per second. So we're good. All right, so I think that's going to cover it for what we can do for performance inside of Twinmotion here. Let's go ahead and jump into the final step of our webinar today, and that's to create our shareable application. Okay, so as a final step today, we're ready to build our shareable application that you can deliver to your users. To do that, we're going to use the media button down here. So if you click on the bottom left here, you'll see media. And in here, we can create a collection of images, panoramic shots, videos, phasing, that's going to be for construction phases and stuff, as well as our presenter, which will allow us to create our virtual walkthrough. So what we're going to do is we're going to create a collection of shots that we want to deliver. They're going to be pre-composed shots, and then finally we'll use them in our presenter so that the user can jump from shot to shot in VR. So from here we'll click on images, and we're going to want an interior shot as well as an exterior shot. Now I've already got an interior shot here. So if I select that, you can see we've got an interior view from that chair. Now we're also going to need our street level view. So let's go ahead and quit media mode here and then move our camera down to a position in the street level area that we'd like our camera at. That looks good. And then we can now click create image, and that creates our new street view camera. Let's go ahead and rename that to street. All right, so now if we click on interior, that takes us back inside, and then street, that takes us down to street level. Of course, from here I could go through on each of these images and click on the bottom right here where it says more, and that will allow me to go in and change things like lighting, exposure, as well as camera settings and special effects and so forth. But we're going to go ahead and skip that for now. It doesn't really fall under the content of our webinar today. So now that we have our viewpoints, we're ready to create our presenter. So we'll go back to our media panel, and this is where we'll create our presenter here on the far right. And we'll click the Create Presentation button here. Now we're going to need to add some images, so we'll click on this button here where it says click here to add media. So we'll select interior first, and we'll drag that down. And then we'll select street and drag that down behind the interior image there as well. So this will give us access to those two viewpoints inside our presenter mode, allowing our user to teleport back and forth between these two vantage points. Now we're ready to create our export. So let's click on the export button here on the bottom left, and we need to make sure that our images are selected here. So we're going to select interior as well as street, and then we're going to go over to presenter where it says empty, and we're going to select our presenter here. We didn't rename our presenter yet. Let's go ahead and do that. We'll jump back up to our media tab here, and then let's rename that presenter, and we'll call it VR presentation. All right, and we're ready to go. Now we simply need to hit the Start Export button. We'll need to specify a directory that we want to save to and simply select that folder. All right, and the export process has begun. And when the export completes, we'll find everything we need to be able to deliver this to our user within this folder. The application is right here, Twinmotion presenter.exe. Let's go ahead and run that. Okay, so here we are inside of the presenter view. You can see it's a little different than the editor view. Down here we have a play button that allows us to play through the different image shots here. We've got our interior shot as well as our street shot. We can hide the menu using this button here, or the interface I should say, and we can simply bring it back by hovering over it there. Likewise, if we want to go to VR from here, just like in the editor, we click the I button on the top right, and then we can click VR, Start VR. Let's go ahead and jump into VR then real quick and take a note of some of the key differences between the presenter application here and the editor. Looking at your left hand, you'll see the menu here is simpler than when in the editor. Clicking on Settings, we still have the Quality Settings button. Back up on the root menu though, you'll probably notice that we don't have access to modify the materials of the scene. We can only adjust the weather and lighting and use the presenter. In the presenter, of course, we have access to our two viewpoints, interior and street. So clicking on street teleports us down to street level, and then clicking back on the interior scene, that takes us back into the interior viewpoint that we created. Okay, so that's pretty much it. Now, if you'd like to learn some more about using virtual reality with Twinmotion or Unreal Engine, you can go to unrealengine.com/learn, and from there you can find the Unreal Online Learning courses. And if you click on Get Started, this is going to take you to those courses. Now, you will, of course, need an Unreal account. I've already got one, and I'm already logged in here. But here we can access all sorts of great courses. So for virtual reality, we can go to the content library here and simply search for virtual reality. And that's going to bring up several courses related to creating virtual reality content. Now, most of these courses are going to be for Unreal Engine and not for Twinmotion, but the courses still have many things that apply to Twinmotion and virtual reality development. And remember, if you want to go further with your projects now from Twinmotion, you can actually link the project into Unreal Engine now, and that allows you to take advantage of blueprints and all of the other great features that Unreal Engine has to offer. If you really need more interactivity, more options, more quality, this is the way to go. All right, so I hope you've enjoyed this webinar. I want to thank you all for attending, and hopefully you were able to pick up some great information on VR development with Twinmotion, or at least a few tips that will help you in your productions. So thanks for coming, and we're going to go ahead and open it up now to Q&A.